Hello, this is a simple electroscope which you can make and should make actually. It's a classic electroscope, and we'll make 3 or 4 different kinds of electroscopes. But these are one way of measuring charge. And so the early people, Coulomb and so on, even Benjamin Franklin did experiments like this. The idea here is that there's a this is copper, so it's a conductor, and it's wound around. There's a lot of winding at the top, and then at the bottom and down here there are a couple of aluminum strips. I just punched a little hole in the aluminum strip and then hung them on the end of the copper wire. And maybe you can use tweezers if you want to. And now this is just being held here, and I actually using the styrofoam block that's actually in your week 14 folder. You can just go pick it out and use it. And I'm just using it as a way. I just punched the copper wire through here so it has mounted and so on, and I taped it down so it doesn't fall over. We'll use this styrofoam block again when we make motors, electric motors. So now, this is all, the copper is conducting and the aluminum is conducting. So now, and there's no charge here, so both aluminum leaves are just hanging down. And I used the thin aluminum, but I mean, if you have heavy duty foil, it'll work also. So I just used a pair of scissors to cut them into 2 strips and then punched a hole in them. So now, this is PVC, which you can buy at a hardware store. And I just cut them into 8-foot lengths. And if you look at the triboelectric chart, which is right here, you'll see that it's a list of materials. At the very bottom, near the very bottom, is the PVC. And at the top are things like, for example, paper or wool or fabric or fur, animal fur. And if you pick 2 things very far apart, one at the very top and one at the very bottom, and rub them together, excuse me, what happens is that, for example, here's just a paper towel and a PVC. If you rub them together like this, give them a good rubbing like this, then the electrons jump from the paper onto the PVC. So the surface of the PVC is actually covered with free electrons. So it's negatively charged. And this is left over as being positively charged. So literally, we've rubbed electrons off of atoms. Now, the reason why they do it is actually very complicated. In fact, it's a subject of research for some people. It has a lot to do with the molecular attraction of these atoms compared to those atoms. And in the end, the atoms here, the molecules here have lower energy levels. Okay, well, you know, atoms have energy levels in them. And so the electrons prefer to jump from here over to here because they go down to a lower energy state. That's basically the reason why. So let's see what happens now. So now you can pick any 2 things off the triboelectric series you want. Here's the fabric and here's a paper towel. So here we go. Let's charge it up, make sure it's nicely charged again. And I'll bring it close to the copper wire without touching the copper. And you see that the aluminum, I haven't touched anything. The aluminum strips spread apart from each other. I move away, they fall back again. I move close, they go apart again. So this is by induction. Literally, the negative charge on the PVC has taken the electrons inside the copper wire and pushed them down to the bottom. The electrons have literally gone to the other end of the copper wire to avoid being repelled by the negative electrons on the PVC. And they go down, and then when they're sitting there on the aluminum strips are now both negatively charged, so they push apart. So let's do that again. Let me just push them closer together. Okay, so now there's no charge here. It looks like there's no charge. They're hanging directly down. This time, just for fun, I'll use the fabric. Okay, here's the fabric. Give it a good rub. There's a certain, okay. And you don't have to go very long, but just a little bit. Come close again, and they go far apart. Fall back again. Now what has happened here, now you see there's a little bit of charge here. I'll go down again and I'll touch actually. I'll come into contact. So some of the electrons from here actually jumped onto the copper. Okay. Now these 2 things are pushing them apart. There's still some charge on here, so if I come close, you see I affect them, all right? Okay. So now there's some residual charge on here. And if I touch it, then any extra charge on the copper wire and the aluminum strips will go into me. So I go like this, and now you see they both just drop down. There's no charge on here. So by touching it with my finger, I'm acting like what is called an electrical ground. So on every electrical appliance, every plug-in, there are 3 prongs. 2 prongs carry the voltage, and 1 prong is ground. And the big prong is ground, and it's literally connected to a water pipe into the ground, which means that any charge you put on that ground plug will go right into the ground, okay, and it'll disappear. So if you want to discharge anything connected to the ground, now it works very effectively because the earth is huge. The earth will accept any amount of charge you give it and never changes voltage at all. I'm not the earth, of course, but I'm much larger than this piece of copper. So I serve as an electrical ground to this piece of copper. So let's do that again. Let's charge it up again. It looks like everything is discharged here now. And I'll go right up and I'll touch it. So I'll transfer some charge to the copper wire here. Okay, so I've transferred some charge to it. Okay. Well, yeah, I want to have them far apart. So if I touch them, they'll probably discharge again. I want them to be kind of... There you go. I charge them up. Transfer some charge here. They're pushing apart a little bit, but they've now separated. That's not a... You can see it's not a very good one. But now they're charged up, and I'll touch it, and they should discharge. And they discharge, just drop down. So that's a simple electroscope, and we'll do another 2 or 3 of them. Thank you.